Hi there, welcome to this video lesson on solving exponential equations with logarithms, utilizing logarithms as inverse functions and operations compared to exponential functions. So I'm going to go ahead and jog your memory with rewriting the expression here, log of 2 to the power of x, using the power property of logarithms. And remember, the power property of logarithms says that if you have a power of an argument, you can go ahead and pull it out front as a multiplier. So I can rewrite this as x times log of 2, right? Where our base here for this log is 10. This is the common log. So here's just a reminder of what an exponential equation looks like. It is an equation where there's a variable in the exponent expression. Now we have trouble when we're trying to go ahead and solve exponential equations because the variable is in the exponent, which is so much different than how we've solved equations in the past. So to undo that, we have to use the inverse of exponentials, which is logarithms. So if an exponential equation cannot be solved by writing with the powers of the same base, if this can't be done, and this is the exponential property of equality, then sometimes the equation can be written in logarithmic form and solved for the variable. Other times you have to use the property of equality. Sorry, that's my ringtone. It's not Darth Vader. So here are the steps that we're going to go ahead and use. Step 1, write the equation with a single term on both sides. You want to isolate your exponential expression. Step 2, take a logarithm of both sides. You can use the natural log or the common log, either one. It's up to you, doesn't matter. And right below you can see here someone really wants to get a hold of me, the exponential property of equality for logarithms. And this just says that if the left side is equal to the right side, if x is equal to y, then if I take a logarithm, the same logarithm of both sides, they're still equal. So it doesn't matter, if it's the natural log or the common log, you can use whichever one you want. I tend to use the natural log. So after we've taken the logarithm of each side, we will use the power property in order to bring down any exponents. And then we will solve the equation using algebra and then state the solution to the exponential equation. So let's go ahead and look at an example. So here is our first example, and we're asked to solve the equation, give the exact solution and the approximate solution to 3 decimal places. So I'll go over both of those here in this example. So the first thing I need to do is isolate my power expression or my exponential expression. So I'm going to add 4 to both sides, giving me 5 to the power of x is equal to 11. Now I need to go ahead and I need to isolate, I need to bring down my variable. So how you do this is you take a logarithm, right, of each side. So I'm going to do the natural log of 5 to the power of x is equal to the natural log of 11, taking logarithm of each side. So now what I can go ahead and do is I can go ahead and use the power property, which says that I can bring down my variable, or my variable from the exponent. So this becomes x times the natural log of 5 is equal to the natural log of 11. So, okay, well, now I just need to isolate x. And how we do that, we're going to divide by the natural log of 5. Divide by the natural log of 5. So here is our exact solution. X is equal to the natural log of 11 divided by the natural log of 5. Again, this is our exact solution. And I would argue this is the most important. most important. Okay, here's the exact solution. So there's the exact solution. I also want to point out too, if instead at this moment, instead of using the natural log, if I use the common log, log of 5 to the power of x is equal to log of 11, I would end up with the same exact answer. I would end up with log of 11 divided by log of 5. And you get the same exact solution. What do I mean by that? Because one's clearly the natural log, one is clearly logarithm. Well, if I go ahead and I go to my calculator, I'm going to calculate these two things. So I have the natural log, ln of 11, divided by ln of 5, or the natural log of 5. And you can see our answer here, 1.4898. So it looks like this is going to be approximately 1.490. So what do I mean they're exactly the same? Well, if instead of using the natural log, if I use the common log, if I used here log of 11 divided by log of 5, guess what? You get the same exact answer. So does it matter which logarithm you use? Nope. You can use whichever one you want. There are some situations where it's better to use the natural log versus the common log, and vice versa, and that depends upon your exponential base. But in this case, you can use either one. I tend to use natural log because I think it appears more often. So here's your exact solution, and then lastly, here is your approximate solution. Okay. Here's a second example. Please write this one down. And this time, again, we're asked to solve, giving an exact and approximate solution. And I have an exponential expression here, 7 to the power of 3x plus 2. Hey, that's different. I now have a binomial as my exponent. Okay, this is going to be a little bit different. But step one, I still have to isolate it. So I'm going to divide each side by 2. Giving us 7 to the power of 3x plus 2 is equal to 250. I want to bring down my exponent. I do that with the logarithmic property, power property. So I need to take a logarithm of each side. So natural log of 7 to the power of 3x plus 2 is equal to the natural log of 250. So now, using the power property, right, that exponent's going to come down in front. And notice how I put parentheses around it. That is very, very important. If you have a binomial, that is your exponent. Very important. Why is it important? Well, I need to go ahead and distribute, that binomial to my natural log of 7, or vice versa, the natural log of 7 to the 3x plus 2. So I'm going to go ahead and do that now. 3x times the natural log of 7 is 3x natural log of 7 plus 2 times the natural log of 7. See, and that's so much different than if I just left the parentheses off. It would be 3x plus 2 times natural log of 7, which is different. Okay, is equal to natural log of 250. Okay, I need to isolate x. So I'm going to undo the addition first. Subtract 2 natural log of 7 from each side. Subtract 2 natural log of 7. We're running out of room now. We get 3x natural log of 7 is equal to natural log of 250 minus 2 times the natural log of 7. And then to isolate the x, I'm going to ask you what operation's occurring here with the variable x. Well, they're both multiplying. So how do we undo multiplication? Division. So I will divide both sides by 3. and by the natural log of 7. Believe it or not, that will cancel with the 3 and then the natural log of 7, leaving just our x. So what you do to one side, of course, we have to do to the other. And we get our exact solution here. X is equal to the natural log of 250 minus 2 natural log of 7 divided by 3 natural log of 7. So there's your exact solution, and then we also want it to be approximated. So let me go ahead and compute this. So we had natural log 250 minus 2 times the natural log of 7 divided by 3 times the natural log of 7. Okay, and here's our answer, approximately 0.279. Approximately 0.279. Okay. I do want to talk about this. If you're not using Desmos or online calculator where you can easily separate the numerator and the denominator, you got to be careful when you're computing this. And I'll put this over here. If you're using like a TI 30, so your calculator should look like this. You need to put in parentheses, you need parentheses off your numerator and your denominator. So natural log of 250 minus 2 times the natural log of 7, close parenthesis, and then close off your numerator again. Very important that you do that. And then you divide, and then you need to open up parentheses for your denominator. You need to isolate your numerator. All those computations need to occur, and then you can divide by the computations of your denominator. So parenthesis off 3 times natural log of 7. So if you're using a TI 30 and you're having trouble, this is what your calculator should look like. Okay, I have a practice problem here. I would like you to go ahead, please pause the video, go step by step what I've been doing, look back at the previous examples, give it a go, and then I'll show you the answer here in a moment. All right, so hopefully you went ahead and paused the video and gave it a go. So here's the solution. Again, you have to isolate your power expression. So the 12x, or 12 to the power of 2x. Then you take a logarithm of either side. Doesn't matter if it's the common log, doesn't matter if it's natural log, doesn't matter if you're using log base 2. Just so long as you're using the same one on each side. Once you do that, you can utilize the power rule to bring down the 2x, and then you go ahead and divide to isolate the x. 1.064 is your approximate solution. All right, here you go. Here is the second practice problem. Note on this one, again, you have a binomial exponent for this one. Binomial exponent. Pause the video. We'll give this one a go. All right, hopefully you paused this one and tried it. Here is the solution. So divide by 3. Then take a logarithm of each side to bring down the x minus 9, and you need to distribute. That's why that x minus 9, very important. Put that in parentheses. So we'll distribute that. You add the 9 log of 34 to the other side, and then you will divide by log of 34, giving you approximately 9.768. Okay. So hopefully you guys did well. I have about, I think, one more example for you here. So in this one, we have 3 to the power of x minus 5 is equal to 13 to the power of x. Oh no, variables on both sides. What do we do? I'll show you how it's done. So on this one, notice I have 2 power expressions. Okay, they're alone on each side, so that's fine. I don't need to, divide or add or subtract by anything. I can go ahead and take the natural log of each side. So natural log of 3 to the power of x minus 5 is equal to the natural log of 13 to the power of x. And here's where I'm going to use the power property. And I get x minus 5 times the natural log of 3 is equal to x times the natural log of 13. Okay, here's what you're going to do. In this example, you want all of your variables on one side. It's like if you're solving something simple like this, like 6x is equal to 3x plus 4. Like, you need to get your x's on one side. So I'm going to go ahead and I'm going to, I guess first I need to distribute. X natural log of 3 minus 5 natural log of 3 is equal to x natural log of 13. So, okay, I'm going to move numbers over to one side, variables over to the other. So I will end up adding 5 natural log of 3 to this side, 5 natural log of 3, and I'm going to end up subtracting x natural log of 13 from this side. So minus x natural log of 13. Okay, so, and I'll keep everything the same color so that way it's easy to identify. I have x natural log of 3 plus, not blue, minus x natural log of 13, which is equal to 5 natural log of 3. Okay, so at this point, you're like, okay, I have my x's on one side. How do I go ahead and, isolate the x? I can't combine, I can't subtract those logarithms. What you're going to do is you're going to factor. I'm going to factor out the x. So I get x times natural log of 3 minus natural log of 13. Okay, and now I can isolate my x. All I have to do is divide. Just divide each side by the items that I don't want. Natural log of 3 minus the natural log of 13. Natural log of 3 minus the natural log of 13. And we get our solution. X is equal to 5 natural log of 3 divided by the natural log of 3 minus the natural log of 13. There's your exact solution. Now we need to go ahead and compute the approximate solution. So that was 5 natural log of 3 divided by natural log of 3 minus natural log of 13. And we get negative 3.746. Oh, negative 3.746. Okay, 3 decimal places. All right. All right, I do have a practice problem for you. It is similar. Here you go. Remember, the whole trick with this is put your x's on one side, maybe in one location like Texas. So then all your x's live in. Get it? The joke? I know it's terrible. Okay, so x is on one side, isolate the x, factor the x out, and then solve. Okay, pause this one and give it a go. All right, hopefully you tried this one. Here is the solution. So after you use a logarithm, of each side, you can pull down your exponents. After you distribute the x plus 7 to the natural log of 19, you get x natural log of 19 plus 7 natural log of 19 is equal to x natural log of 5. Now it's just shuffle. I'm going to move all my x's over to the left, you know, the x natural log of 5, and I'll move the 7 natural log of 19 over to the right. And then I can factor out my x. So here, x times natural log of 19 minus natural log of 5 is equal to negative 7 natural log of 19. And then I just divide. So you should end up with the solution negative 15.439. You might end up with a different exact solution. If you moved this x natural log of 19 over to the right instead, if you just subtracted, then you may end up with this answer, 7 natural log of 19 divided by natural log of 5 minus natural log of 19. Okay. All right. Hey, that's going to do it for this video. We went ahead and solved exponential equations using logarithms. Catch you next time. Be safe, be easy.